Hello everybody, my name is Lorenz Bernauer, I'm from Melitica. Melitica is a young company. We aim to simplify, to reduce the amount of emails daily written in companies, especially targeting enterprises. And my talk today is about the auto-generation of email responses. First, email is dead, email is alive again. I guess everybody here has heard that before in the last years, even decades. And first I want to assess what's the current state of emails. Are they increasing in terms of significance or are they decreasing? The first is a survey which has been conducted in 2017. Revealed that 270 billion of emails are written per day. And if you break this down to a normal office worker, that would be an average about 220 emails. So that's quite a large amount, isn't it? And if this is being considered in terms of average working hours, that's 3 to 3 hours per day, which is also quite significant, and there's truly some room to improve to free working time and to assist in terms of writing emails. At the same time, another survey conducted by Adobe in 2017, it revealed that about 72% of consumers still expect emails to be the primary source of communication in terms of business. So it's kind of obvious emails are still really important, and it doesn't look like it's losing significance. The problem is nowadays, on the other hand, the world changes, the requirements in business changes, and for example, now speed matters. Emails are being expected to respond really quickly. In the best case, at least at the same day, better in some hours, or in the best case in some minutes, right? At the same time, context and information matters, which means an email response should be aligned to the customer's request, and it should contain a high degree of information. The problem is those two targets actually contradict each other a little bit. If you want to answer as soon as possible in email, you're not being able to enrich that email with various information, for example, from other systems such as CRM or ERP. At the same time, if you want to enrich it with a lot of information, you're not being able to answer that email so quickly. And there are other issues we are tackling. For example, who likes to be engaged for almost half the working day interacting with an email program, writing and receiving emails. There's certainly more important things to do. Also, we actually realize in an analysis many emails are written again and again. Of course, the word choice varies a little bit, but the content of the message is actually identical in terms of customers' request and in terms of the response which is written. And this actually cries for some automation to generate email responses, to propose them, and that's our vision of Melitica to do that. And also those challenges I just showed here are the main drivers of Melitica. So imagine in the future, your email program already proposes topics being assigned to incoming emails. So before you even open one email, you already know, okay, that's about that topic. For example, a customer request about the delivery time, if it's a manufacturing company, or it could be an application in terms of HR. That's where can be even more fine-grained, and it's always customer specific. And of course, how nice it would be if, according to the assigned topic, an email response is automatically drafted and proposed, so the user just has to have a look, can add more information, or can delete it as the user wants. And for sure, the proposed email is also supposed to be enriched with information, which means, again, to the customer request about delivery time. And the proposed answer should actually consist of the the delivery tail, which is being pulled out from other systems. So as I said, this is what we want to accomplish with Melitica. So we have for areas we are tackling, first email classification, which means the incoming email should be checked against the classifiers, and a topic should be assigned. Next one is email smart responses, which means according to an assigned topic, an allocated topic, a smart response should be drafted and proposed for the user. And later on, I'm going to show a live demonstration about those email smart responses in particular. Email routing could be additional, that the email is also being routed to a certain person, to a certain department. And email text analytics is supporting all three others. That's about, for example, feature engineering, extracting dates, times, etc. How does Melitica work? It's more a little bit technical now about what we're using here. It's written in Scala for the feature engineering part, for analyzing and stripping down the incoming emails. So for the natural language processing part, we're using Spark NLP. Our supervised and unsupervised classification models or machine learning models are run on Spark ML. And for the actual natural language generation of our smart responses, it's also based in Spark, but in custom implementation as a Spark ML transformer. So Melitica is divided in two different phases. We start first with a preparation phase. That means an email base, an email account is being analyzed. Underlying topics are being revealed. That's what we're having here, our topic detection algorithm. And those topics are being assessed by the user. They can be activated or deactivated. And this preparation phase serves later the production phase. Important to know is, even for our supervised learning models like text classification, there's no manual labeling required by the users. It's all being done by our algorithm, that we use the connectivity of emails to assign labels. So all what needs to be done is connect the email inbox, topics are being assigned, classifier for those topics are being trained. That's what we're having here. And once this is done, Melitica already can be used for the production phase. And that's why I'm going to demonstrate now live. What's happening is that emails are being acquired by the email connector. It's being matched against each topic, and at the end, a topic is being assigned, and also a smart response is assigned. Okay. So currently, the entry point of our application is just like source code based, because we don't have a graphical interface yet, but you cannot see that actually here. Okay. All right. I prepared an email box for this presentation. What we are seeing here are emails which really resample real-world emails, which are, of course, the names, everything is randomized. There's no information revealed. This email box now represents a normal email box as it could be as a customer site. And I'm going to run now our algorithm against this email box and our target. You can see now there are no drafts, for example, written, like here on the left side. There are no drafts, there are no labels, nothing. You just have the plain incoming emails, nothing more. What I'm going to do now here, that's what I just spoke about. I'm going to run now our program. Okay. It connects now with our email box. It retrieves our emails, analyzes, and pushes back our smart responses. I'm just going to let it run now in the background. It takes about 3 to 4 minutes, and meanwhile I'm returning to our presentation. And that's now the wrong mode. All right, so our program is working on the background. What's happening is that we're going to acquire those emails with our email connector. The email is being processed in terms of feature engineering. The email classification happens at the end. The output is our email smart response. Our email connector, just to give some background, it can be connect with POP3 accounts, just like for the standard and SMTP. But also we can speak like what you just have seen now with the Gmail API. So it's more vendor specific, or in terms of enterprise, it's quite important, Outlook and Microsoft Exchange API. The email processing path is really important because emails are by nature quite dirty, which means you're always having a lot of history which needs to be stripped down because the incoming email is only the content of the incoming email should be considered. And the legal part of an email, like Impressum in German, usually is really huge compared to the actual email message. So this all needs to be stripped out to have the real content in hand. Once this is done, what we are actually receiving is a feature vector, which is passed to our classifiers. Each email is being matched to each single classifier for each topic, and it's a binary outcome yes or no. And it's a one versus rest scenario, which means the best topic wins at the end. But quite important for us, it's important, we want to avoid false positive by any cost, which means we also added some algorithm to let the classifiers decide, no, we are not confident enough here, we won't assign anything, we won't propose an email smart response, and just give it back to you the message as it is, and the human user has to take care about drafting a response. Yeah, and the final outcome is our email smart response. But once the classification has been done, the smart response is pushed back to the email box as a draft. So the user has the freedom at the end to see what's being proposed. The user has the freedom to change the answer or even delete it as he or she please. So the goal is that Melitica is helping, is assisting in terms of writing emails, but it's not taking the whole responsibility, so to speak. Okay, so I'm going back now. I have to switch here again to duplicate. Our program is still running, but I already can see like something is done here, so we switch back to an email account. I will refresh here. And what you're seeing here now is already first the labels are being assigned, like about what topic the incoming customer request is. You can also see on the left side drafts has already been added. We're going to go now soon in detail to check to see what's being written. You see the various different labels, so it's not like just one or two labels, but at the end it can be n topics, there won't be any problem, and each topic could be activated or deactivated according to a precision which is required. For now, the program is actually done, or the whole email base is analyzed, and we're going to have a look now. I will just start now, for example, with that email. It's apparently a Bestellung, an order from our customer. My apologies that it's all in German here now for the English speaking, but it's a German-based customer, or the email base is coming from there, and that's why it's like that. What you can see here is it's indeed an order if you consider the text, so we already know this is correct, what has been assigned. And what is being proposed now is the answer here. Rather simple, but it's truly perfect, and it's also written. It's the same answer what is usually written in that company, which means the smart responses really speak the company's, the enterprises, or the person's language. And yeah, the whole email is being drafted here. Something can be added, doesn't have to be, but if it's fine, it can be just sent to the customer as it is. I'd like to show another example. For example, here it's a request when the customer requests about the estimated delivery time. So again, here we can see the label, the topic assigned is correct. If we have a look at the response, it's also obviously correct in terms of grammatic, but also in terms of the content of the message. What's important to know here, what's not done yet, but soon to come, that the email is also being enriched with live information. For example, here, it could just pull like the ERP system and get the estimated shipping date, and the email can be sent to the customer without any interaction, and the user doesn't have to do something at all. And that's pretty cool. If you consider that, it's a lot of keystrokes you save, a lot of time you can save, and the email can be just sent. Also, what I already mentioned before, what's happening if something is being sent by a customer which doesn't make sense at all for this particular business case. Like, for example, here, maybe this message was just sent by an accident to that company, and obviously no topic would fit in the past, from the past history. And here you can see our program didn't assign any topic. It didn't draft any smart response, but it's just like the user has to take care of that. Okay. Yeah, I just want to show one more case here. I don't want to go into detail what it is about, but you can see even rather long responses are perfectly in terms of grammatic and content. And this really reflects exactly what would have been written on the customer side. Okay. One moment, please, I have to switch back here. I just have to jump one again, my apologies. Okay. So you've seen now how the email pipeline works, how email is being acquired, being annotated, classified, and a smart response is pushed back to your email account. So if I sum it up, what's important to know, again, it's really like the training, even though it's supervised training, it's text classification. There's no manual labeling required. So it really scales well. If there's an email box with 10,000 emails, no problem. If it's 100,000 emails, also no problem at all, even if it would be more. There are basically no boundaries. All those trained customer-specific, all those trained machine learning models, like language generation models, classification models, and cluster models, are being customer-specific, and of course they're also being owned by the customer and they stay at the customer. So there's no sharing, but it also means the responded emails really speak the language of one enterprise. It's self-learning, which means, sure, our classifiers do make mistakes, like sometimes there's a false positive, but this feedback is going back to the system, and then in the next iteration, the next training iteration, this is actually incorporated, so the precision increases with time, of course. And needless to say, there's an improved efficiency on the side of the user. Many keystrokes are saved, much time is saved. It integrates really easily into other systems in terms of the email connectors, what you just have seen now, but it also integrates easily to talk with our system, like via REST, for example, to pull out other data. That's no problem at all. And of course, our solution is highly scalable. If there's a peak, for example, it's Christmas time or something else, it doesn't matter at all. If there are more emails coming in, Melitica basically can handle it. Yeah, that's already my presentation. Thank you very much for your attention.
So are the topics given?
The topics are not giving. What's coming in is the email box, the email account, so to speak. And by using LDA, for example, in k-means, we reveal the underlying topics and we propose those topics. So the topics are specific for each email box for each customer.
Okay, so I could have different topics in my mailbox than my coworker.
Absolutely, yeah. You certainly do.
How do you ensure quality?
Of course, yeah, of course, the assessment of quality of a clustering model is always sort of difficult. That's true. What we did here, we already, for each proposed topic, we are also generating in advance a smart response by first training the language model and then generating the smart response as it would be most likely to appear for that certain topic. And then it's actually already really easy for assessment. You just have one look and you can tell, okay, that topic makes sense. That's a known answer I've written before and it's correct English or German. Or you just see easily, no, I won't activate, that topic won't go into production because it just obviously doesn't make sense. And that's our way of assessment.
But do I understand it correctly? What you get with LDA is kind of a distribution of words for each topic which should be semantically coherent.
Okay, that's correct.
In the end, you choose one term to label the email, or
Yeah, I have to correct about that. We first use LDA, we moved then to k-means because it works much better. And the outcome is, but in either way, the outcome is the best fitting topic, the best fitting cluster. And that's the topic assigned. But for each paragraph, which means an email can have actually more than one topic if there are more paragraphs. That's how we split it on. Yeah. Yeah, go ahead. Mm-hmm. Yeah.
What's the label for that topic? Is that one of the words from the paragraph, or?
So, what did you say?
So when you classify a particular paragraph into a particular cluster, right?
Yep.
Like it's cluster 1, 2, 3, 4.
Mm-hmm.
But then how do you label that cluster? How do you know what to name this cluster? Is that a word from that cluster already, or?
First, we propose the smart response, the most likely in smart response. We also propose the words which are most likely to appear in this cluster, in this topic. And the final assessment, actually, or the final labeling has to be done manually. So you would say by hand, then okay, that's an order, that's a price request, etc.
And the second question,
yeah.
For the smart response, for each topic, do you have like some sort of list of probable responses, and then you generate more from that, or how do you bootstrap that? Because if you really try to generate a textual paragraph which is that long, there's very little likelihood that it would be somewhat grammatically perfect to begin with, let alone that it answers the question.
Well, like for each topic, a specific language model is being trained. And that's why the size of the language model is rather small, and that's also why it really gives you a clear path how the most likely message would look like. So we start having nothing written, and we just tell the model, give me the most likely word you would start with answering that topic. And that's what we're getting, and then it goes, it keeps going on, like having this history of words, having this history of n-grams. What's the most likely next word? And that's what we do till this paragraph, till the message ends. Does that answer your question?
Yes.
Okay. Yeah.
Can you say something about the reliability of the system in a real context?
The reliability is in terms of precision about the classifier.
When the smart answer is aligned with what the user would write.
Yeah.
In many cases out of 100.
So I have to differ between classifier and smart response. First, classifier. Of course, it depends like what's more important for you, precision or recall, so you can adjust the confidence threshold. And also about classifier, it highly depends on the data, how much data is provided. And yeah, you can actually activate and deactivate single topics based on the target precision you want to have. And in terms of the proposed smart response, in our observation so far, it was like that whenever a topic made sense and the email were correctly classified, the proposed smart response, the generated response, was always perfect. We never had any problem that it didn't make sense. Yeah.
Do you have a real-world example, and how large is the training cost?
What you have seen here the preparation phase behind, which just worked here as well, is coming from a real-world example, and it's coming from an email corpus which contains about 500,000 emails. So it's rather large, and it performs really good on that. It doesn't. The aim is not to replace any written email, of course, but especially those emails which are repetitive are supposed to be replaced, and in this case, it works well.
Any other question? Then we are ready for the lunch break. Thank you again.
Okay.